Education is the foundation of success. I am Mrs. Nitya, Assistant Professor working in the Department of Artificial Intelligence and Data Science in Kamaraj College of Engineering and Technology. Today we are going to see about the linear regression. So let us discuss the linear discussion. We know about what is machine learning and what are all the machine learning types that we are already discussed. So in machine learning there are two mainly types, that is the supervised and unsupervised learning algorithm. So in supervised means the class labels has to be identified in the correct manner, that is known as we have say that is the supervised learning algorithm. In supervised there are two types, the first one is the classification and second one is the regression. In classification the output label contains either 0 or 1, true or false, like that we have to predict the output label, right. In regression the value can be in the continuous manner. For example, if we take the house prediction, house value prediction, depending upon the input attributes the output values can be randomly changed, that is known as regression, right. So in that regression now we are going to see the linear regression. This is the simple linear regression algorithm, one of the simplest algorithm in machine learning techniques. So before let us discuss about the linear regression, we can just see the use case scenario. So if suppose if I am having 5 rupee coin, I want to buy some chocolates, that is dairy milk chocolate. If suppose if I am having 5 rupee, how many chocolates I can buy? Only one chocolate I can buy. If suppose if I am having the 10 rupee means I can buy the 2 chocolates. If, for example, if I am having no amount, we cannot buy any chocolates. So like that I can give the input of amount and the output label how many chocolates can be buy. So in the data set, in this data set I can give to the model, and in tomorrow you can give a amount of 5,000, my model can predict how many chocolates can be buy for 5,000. So if the system can be correctly predicted me, so this algorithm will be suited for that particular application, right. So this is input and this is output. This is input, I am taking the amount value, how much amount I have, in how much amount I can buy, how much chocolate can be buy. So I can give the machine learning model. The machine learning model can learn these patterns and give the predicted amount. This is known as supervised machine learning algorithm. So in simple linear regression, what do you mean by linear? Linear is nothing but a straight line, we can say. So in simple linear regression, it is a statistical method. It is a statistical method for establishing the relationship between the two variables. Here what are all the two variables? So input is the amount and the output is how much chocolates I can buy. So the relationship between the two variables, I can draw a simple line, a straight line, that is known as a simple linear regression. So if I am drawing the straight line by using the two variables, that is known as linear regression. So now I am going to take this input. Now for simple linear regression, I can represent the input and output. So the relationship between the two variables is known as the linear regression, no. So I can represent these two values by a graph. So basically in graph there is x value and there is a y value. Here I am taking the x value as amount and y value as the how much chocolates I can buy. So based on the input data set, I can point the amount and the chocolate values. So for 5 rupee I can buy the 1 chocolate. So 5 rupee I can buy the 1 chocolate. For 10 rupee I can buy the 2 chocolates. So based on these input data, I can draw the data set as a graph. I can get the straight line equation, I can get the straight line in the graph. So basically in the mathematical manner, a straight line can be represented as some mathematical formula that we are all know, that is y is equal to mx plus b. So y is equal to mx plus b means y is a new point, right. So m is as we already know, m is a slope and x is the given input and b is known as intercept. So this is the equation of a line, y is equal to mx plus b. So where y is equal to the new line that we are going to draw for, suppose if we are giving 100 rupee, if we are giving 5,000 rupee. So for 5,000 rupee, how many chocolates I can buy? So y is a new point, a new data point, and m is the slope. So that already we discussed in the class. M is calculated as y2 minus y1 divided by x2 minus x1, and x is the input data set and b is known as intercept. So based on this equation, now I am going to let us consider some values for slope and intercept. So slope is 10 and intercept is 20. So we can give this input to the input data set for the equation of y is equal to mx plus b for getting the new prediction data. So the line equation is here mentioned as y is equal to mx plus b. Okay, so for that y is equal to mx plus b, now I am consider m is equal to 10 and b is equal to 20. So first data, this is the given input and this is the y and this is the substitution value. So y is equal to mx plus b, m is considered as 10 and intercept is 20, right. So after calculating everything, I can compute the new value as y. So y is equal to the first point 70, second point 120, 170, 20 and 720. So after computed the y value, I am going to draw some graph. So for x is equal to 5 means in this answer I can get the y value as 70, right. Okay, right. So now these are all the x values and these are all the y values. Based on this, so first we have consider, so x equal to 5 and y equal to 70. So x is equal to 5 and y equal to 70. So x is equal to 5 and y equal to 70. So these actual line is the actual one and this our line is the predicted. The model can be predicted the new value. So whether now we are going to compute whether this input is this considering the m and b values are correct or not. So 5 comma 70, next 10 comma 120, 15 comma 170, this is the predicted value. So now you have consider for amount of 30 and now I am having the 30 rupee, how much chocolates I can buy? So how much chocolates I can buy? So amount of 30. So just listen, this is the actual input and this is the predicted output. So now I am getting 5 comma 70, 10 comma 120, 15 comma 170. Now I am going to test the values. So for example, if I am taking the value as 30, so in 30 how much chocolates I can buy? So x value is 30 and y value is nearly 300. So 300 means it is ethically correct. So for 30 rupee can I buy a 300 chocolates? Wrong. So how much for example for 30 rupee I can buy a 6 chocolates, right, but it shows the 300. It's a huge error, huge amount of value can be different. So actually so how we can calculate the error? So error is nothing but predicted value minus actual value. So what is the predicted value? Here they can see the 300 is the predicted value and the actual value can 6. How I can say the 300 is the predicted value? For 30 rupee I can buy only 6 chocolates, that is actual value, but in my graph what is the output? It showed 300. So 300 minus 6, what is the error rate? 314 is the error rate, right. So it is a huge error. So we can reduce that error so that we can predict the correct output. So always best line equal to 0 error. Squared error, mean squared error is nothing but they have some formula. For example, 1 by n summation of I is equal to 1 to n yi minus yi the whole square the cap. For what is the error rate? This is the error. As we already discussed, that is predicted minus actual. What we get the predicted value? 300. What is the actual value? 6, right. So 314 the whole square means we can get the huge value. So let's consider if suppose the output value can be the huge value, means we can reduce the optimized algorithm. For that we can reduce the slope and intercept value. So it's a simple one. Here n is the total number of points. So here we taken the 5 means 5 is the n is equal to 5. This is sometimes called as cost function. So cost function is nothing but there are two functions, cost function versus loss function. Loss functions refers to the error computed as a single data point. If you take a single data point and if you calculate the loss, how much loss can be error, that we already know, that is predicted minus actual the whole square divided by 2, because only one point we will take. So n is equal to 2. So that is known as loss function. If we consider the whole data set, means that is the cost function for that particular data set. So for that cost function we can use these mean squared error and the loss function we can use 1 by 2 y minus y cap the whole square. Okay. Now as we already know, m is equal to 10, b is equal to 20, we can get after applying the computer new value. So, just apply in the formula for mean squared error, we can get these errors that like that actually 1, 2, 3, 4, 5. There are 5 data set. N is equal to 5. Yi minus yi cap the whole square. So, this is the error rate. This is predicted value, and this is error, and this is squared error. So, summation of these squared error, we can get these number. This is 6-digit number. Okay, right? These 6-digit is a huge error. Okay. So, we can reduce these error by adjusting the slope and the intercept. How we can adjust it? Just we can assume. So, now I am going to consider intercept value as a 0 and slope value can be as a 1. After calculating these calculation, I can get the answer as 672. In previously I can get the 6-digit number. Now I am reducing the slope value by 1 and intercept value by 0. Now I am getting the value as 672. 672 is also sum of 3-digit number. As I already told, 0 is the best line. 0 is the best line, right? So we can till reduce the slope and the intercept value. So, after reducing the slope value, so first we can consider the 10 and next we can consider as 1. Now we can consider as 0.5. So, 0.5 as a slope and 0 is the intercept. Now I am getting 94.5. First 6-digit number, 3-digit number, it is a 2-digit number, but still it will be reduced, so that we can get the correct predicted answer, right. So, in next step, I can consider m is equal to 0.2 and b is equal to 0. So, after considering 0.2 and 0, I can get the error as mean squared error as 0. If suppose if I am getting the mean squared error as a 0, that slope and intercept value should be correct. So, after calculating these errors, now I am going to draw some graph for these input and the mean squared error. So, for that, for calculating these slope and getting the mean squared error, I am drawing some graph for this particular data set. I am getting the function for U curve, right. So, this is the high point, this is the low point, this is the minimum point. So, this point is known as at any cost in one point, the minimum value should be the considered as a 0. So, in here in 0.2 the mean squared error is a 0. So, this is known as global minima. This value is known as global minimum. So, why we are considering the global minima? Because these values are assuming by, let us consider by us. So, this point is known as global minimum. So, the global minima, the point at which a function that takes a minimum value is called a global minima. At any cost, the error will be the 0. So, that point we can consider in a graph. So, that point is known as the global minima. So, for finding the global minima, we have some algorithms, that is optimization algorithm, gradient descent algorithm. So, for finally, what we are doing in the linear regression, this is very simple algorithm for finding the equation. For suppose if I am giving the input for predicting the new output means, we can use, if suppose this is the relationship between the two variables. So, this is the simplest and easiest algorithm to understand. So, for the given input data set, I can predict how much value of data can be, how much value of counts of chocolates can be retrieved. For these data set, what are all the steps we will be done? First we have to calculate the straight line equation, then consider the m and b value, then we have to find the continuously error checking mean squared error for performance metrics, then we can reduce, if the mean squared error has to be highest value means, we can reduce the error by finding the right values of m and b by using the global minima algorithms, that is gradient descent, and some of the algorithms can be used to minimize the m and b values. So, these are all the steps to find out the linear regression equations.